Hey Sammy, so you wanted me to explain to you black holes this week, and I have not uploaded my video from last 2 weekends ago. So today I'm just going to give you a double video feature because I'm late and I haven't uploaded the one from before. So I'm just doing all sorts of bad things right now. Alright, getting right into it. So, stars. Stars usually live out their lifetime as like our own. Last minute edit. It goes hydrogen, helium, and then carbon, eventually gets to carbon, and that's where I messed up and continue on. And finally, in this carbon dense core, the pressure will eventually just throw off all the remaining helium and hydrogen into a planetary nebula, which are those really pretty pictures you see. So that's what happens if you have a regular star. If you have a supermassive star, you'll end up with a black hole instead of this little carbon white dwarf. So a white dwarf's what's left over, by the way. So if you have a bigger star, it doesn't end at a white dwarf. It gets crazier. For these supermassive stars, it doesn't stop at the carbon. It just keeps going and going until you get to iron. And then at that point, you are in trouble because you can't really go much further than that. Because even though you have this huge massive star and the pressure has enabled you to go past carbon fusion, you're not going to be able to go any further than that just because that's as big as you can get. So these stars last a very short time. They live hard, party hard, and die hard. And they die in a very special way. This iron core is a bunch of atoms, which are protons and electrons, essentially, if you forget about the neutrons. And what happens is all this mass around the iron is just crushing down on this thing. So you have a mass the size of a star that's larger than the Earth, all compressed down, and eventually this pressure just crunches the electrons into the protons, and they can't stay apart from each other. They can't electromagnetically repel each other, and gravity just wins, and they all collapse into neutrons. And so all of that space that is usually between your atoms is no longer there, and that just releases an immense amount of energy as it collapses down into a neutron star. And what happens is when that occurs in the core, everything just gets obliterated, and for a very short period of time, these explosions, these supernova explosions, outshine their entire galaxy. So if you see one in a distant galaxy somewhere out in space, it looks brighter than the whole entire galaxy that it's in. It's really cool. If a star's unlucky and massive enough, during that supernova explosion, enough matter can fall back down onto the neutron star that it exceeds what most scientists estimate to be about 3 solar masses. So three suns in the size of about New York City. Imagine that. That's ridiculous. That sucker ain't coming back. It's going to be a black hole because it just crushes everything, pulls light in, nothing can escape. And that is how you create a black hole. They have been observed in the form of supernova disappearing and not leaving behind a neutron star. So we know that something's there, it's just can't see it. And so you assume then that there's a black hole there. We also have 2 other types of black holes. We've talked about stellar mass black holes, but really there's also supermassive black holes, which exist in like the center of galaxies. So those aren't your common everyday black holes, but they have been indirectly observed. We can see the one in the middle of our galaxy just kind of chilling there, whipping stars around it like there's no tomorrow. And then there's also the third type, which is microscopic black holes, which are theoretical, but the Large Hadron Collider in Switzerland is hoping to see them possibly for the first time this year, maybe in the next 5 years. We'll see. They just turned it back on, and the light show is going to be pretty. We'll see if they find one. I'll make a longer video at some point in time if you're interested. Let me know when you leave St. Louis. I don't know if we've told the internet where you're going. I'll let you tell that if you want to. But yeah, I'll talk to you later on Monday. Bye.